With the successful testing of this new engine, Elon Musk and NASA are one step closer to accomplishing their shared goal of exploring the depths of space. This partnership has been going on for a while. They have introduced a light-speed engine that is quicker than anything ever seen in the aerospace business after years of testing. The fact that this engine can survive the meteorite ordeal and reach Mars successfully sets it apart from the competition. There are different opinions in the scientific community about the new light-speed engine's potential, which is one of the problems with space travel. Elon Musk wants to make it possible for people to go to Mars safely by the year 2050. Elon has a track record of delivering results, so NASA is working with him to achieve that. However, the thought of traveling to Mars, our solar system's fourth planet, has presented a number of challenges. Today's rockets use methane as their primary fuel, rather than the kerosene used in the past, since it would take at least 7 months for a rocket flying at 15,000 miles per hour to reach Mars, which is situated an average of 140 million miles from Earth. This fuel must be prepared in advance and loaded onto the rocket prior to launch in order for the mission to succeed. But in terms of fuel in space, how much would a rocket that burns 11,000 pounds of fuel per second require? The short answer is a lot, and this is considered when designing a rocket to do such a hazardous mission. The weight and fuel efficiency of a spaceship must be balanced when designing it. The majority of the compartments that contribute to the weight of the craft are set aside for retaining fuel and supplies, leaving only a little section for the astronauts if you were to examine the existing Starship for the unique mission to Mars. A spacecraft is 120 meters above the Earth and has 33 Raptor engines with a 500,000-pound thrust capacity. Even though the engine is designed to be fuel efficient, having adequate fuel for a trip to and from Mars will be difficult. This explains why all of up to this time successful Mars trips have been robotic flights utilizing smaller rockets, as astronauts will not need to utilize additional fuel or supplies required for a crewed mission. Even Elon Musk, who has acknowledged that such a travel will be dangerously difficult and crowded, as well as requiring additional fuel added to an already hefty vehicle and increased expenditures, is aware that there is a bumpy road ahead if they were to safely launch the rocket into Mars orbit using aerobraking. Chemicals are frequently the new engine's promise. Rockets are based on the third rule of motion, which states that the action and reaction forces must be equal in magnitude and directed in opposite directions. This notion is supported by the Falcon 9 space shuttle and the current Starship in production, as they all rely on thrusters to generate thrust. The hot exhaust produced when fuel like methane and oxygen are mixed in a combustion chamber frequently gashes the skin. To hasten takeoff, steam and water are directed through a nozzle. This light-speed engine, however, seeks to defy the laws that have long been in force. It won't need propellant to move because of the rules of spatial relativity. As one approaches light speed, objects become heavier. Ions are accelerated to moderate speeds in a loop, and their velocities are then adjusted just enough to change the masses of the ions. The engine will have a helical structure, like a stretched-out string, with no moving parts other than the ions trapped in magnetic and electric fields that will be propelled back and forth in one direction to produce the necessary thrust. This high-speed engine intends to generate thrust without the use of fuel by employing contentious electromagnetic drive technology. David Goodwin noted that if the vibration from the electromagnetic or ions can be directed in one direction, any rocket may be driven into space quicker and farther than any other propulsion system ever used. It may eventually create a potent propulsion system that allows it to move at speeds that are only a tenth of the speed of light. A propellant-free propulsion mechanism is not a brand new concept. In 1990, Goodwin oversaw a NASA study that helped establish the discipline of propulsion physics. In actuality, Roger Scheuer invented the first machine in 2001 that showed how the idea of a reactionless drive might work. If the new light-speed engine holds such enormous promise and could allow humanity to explore the high heavens, why are scientists hostile to it? Since the first demonstration in 2001, scientists from the UK, the US, and China have demonstrated how electromagnetic propulsion would work. However, critics claim that this does not mean it is time to celebrate, because it is unclear how the propulsion would be used in practice, since the earlier tests were not conducted in a vacuum. Because you cannot ionize particles in a quantum vacuum and as a result cannot produce energy, if these studies evaluating the little effect of the device were to be deemed relevant, it could result in measurement mistakes and uncertainty before the project can even get off the ground. With this, we conclude our video. We appreciate you helping us keep it going by watching. The best way to support our channel is to watch another episode. Thank you for tuning in. To ensure that you never miss an episode, please subscribe to the channel.